All right. I hope that everybody is ready to start our first set of notes. Nothing that we are going to be talking about is new. Everything in this set of notes should be just straight review. All right, so we've already talked about how in physics we do a lot of labs. Well, as we are in our labs, we are going to be collecting data. All right, so the reason that we collect this data is so we can analyze it. All right, so we want to figure out, we've said this over and over and over again, we want to figure out what those relationships are between our variables. All right, so we represent our data visually in different ways. We're going to be talking about those different ways in order to help us see those patterns. All right, so we've seen different patterns like a positive slope. We've seen negative slopes before, and we know that that positive slope tells us that we have a direct relationship. A negative slope tells us that we have an inverse relationship. All right, so all of these, whenever we collect this data and put it in some visual form, we can easily see all of these trends, patterns, and relationships. All right, well, whenever we are collecting this data, there are two different types of data that we can collect. The first one, again, everybody should know this. The first type is qualitative. All right, so that sounds like quality. All right, so whenever we think of qualitative data, all right, what we're really doing is describing something. All right, so it's descriptive. All right, so if we take the Let's Bounce lab that we did the other day, okay, so we could have taken data on colors, all right? So we could have chosen a red bouncy ball and then compared it to the bounce of a blue bouncy ball to see if that changed things, all right? That wouldn't have been a great lab, but we could have done it, and that would have been qualitative. A really good part of a lab, so data that you could have collected, excuse me, I had a brain fart there, that data that you collected the other day that could have actually been super helpful could have been the types of surfaces that we bounce them on, that we bounce the bouncy balls on. All right, so types of surfaces is descriptive. All right, so you could have done all three of our trials on the desk and then turned right around and done 3 trials on the floor in my classroom. And then you could have turned right around to do those same trials in the hallway. All right, all 3 of those are different types of surfaces, and none of them are going to be quantitative. Like, you can't quantitate a desk, you can't quantitate the floor, you can't quantitate the hallway floor. All right, so those would be descriptive, but that would have given us an awesome set of data to compare each other to. All right, the next type, this is the type that we use most often in physics. All right, that's something called quantitative. All right, so we think about the term quantity, and all that means is that it has numbers. All right, last year in chemistry, we used things like temperature. We saw temperature last year. We used density, we used volume, all right, we used pressure, we used amount. All right, do y'all remember moles? All right, that was measuring amount. All right, so all of those are quantitative. This year, all right, we used mass last year. We're going to be using that again this year. The other day, whenever we were working on our 4-step method review, we saw that we used time, we used distance, we found speed, which is also velocity. We're going to be finding acceleration. We're going to be finding force. We're going to be finding work. We're going to be finding energy, different types of energy. We're going to be finding power. We're going to be finding momentum. We're going to be finding something called the period of a spring. We're going to be finding frequency. All right, so these are just a few things that we're going to be finding this year and doing labs on, and all of these are quantitative. All right, they all have numerical values that go along with them. All right, so once we collect this data, whether it is quantitative or qualitative, all right, we don't just write things down willy-nilly. We always put them in a data table. All right, so I tried to get a data table that was similar to the one that we saw in the Let's Bounce lab. So you see here, we've got 3 different trials, and then we've got an average. You don't really have to look at this right now. We're going to talk about how that's found later. All right, but what I really want you to look at is the average time here and then the distance over here. So data tables are pretty good at kind of introducing us to maybe what a relationship or what the relationship is between our variables. So if you look at that average time, as you go down the column, you can see that your time decreases. Well, as you go down the distance column, all right, you can also see that your distance decreases. So what we can see here is that we are starting to see that there is a direct relationship between these. All right, but you really have to be looking for that, and you have to know what you're looking for because there is a lot of data in this data table. So in order for us to better represent our data, in order for us to be able to more easily see those relationships, we're going to turn those data tables into graphs. All right, now, we want to choose the right graph for our data, and these are just some of the types of graphs that there are. Now, last year in chemistry, whenever we started talking about graphing at the beginning of the year, you were given an assignment where you were given 4 different data sets, and you had to figure out what type of graph would be best. All right, so one of those, we did use a bar graph. All right, and that is whenever you're comparing categories. So we use bar graphs more with qualitative data more than quantitative data. All right, so you can see right here in this bar graph example. All right, you have your types of fruit down here. And then we really don't know. This is a problem on this one. All right, in class, we talk about how we need labels for our axes. So, I mean, we can kind of assume that apples, bananas, and cherries are types of fruit. But over here on the y-axis, we really have no idea what that means. All right, does that mean age groups? Does that mean number of people? Does that mean tens of thousands of people? Does it mean tens of millions of people? We have no idea. All right, so we do need that label. But what I really want you to see is that these are descriptive. All right, these are qualitative. All right, so we would use this bar graph for this. Another type, this is the one that we are going to be using 99.9% of the time, is a line graph. All right, so these really are able to show trends. Again, those trends are relationships over a certain amount of time. All right, so this is what we're going to be using. This is very much quantitative. Very much quantitative. All right, you can see down here, I chose this example because it makes me angry. All right. So hopefully you're looking at this and you're like, oh my gosh, there are so many things wrong with this. Okay. Now I understand why they did what they did, but for our purposes, we will never do what they did in playing Connect the Dots. They played Connect the Dots. We hate, loathe, and despise that. So we will never, ever, ever do that in here. All right, but if you were showing a graph, say you were working in a business and you wanted to show, that your profit margins for your quarter, all right, whatever quarter you were in the fiscal year, and say like April wasn't such a great month for profits, you would see that dip in the profits, but then in May it went right back up. So like in everyday life, you would probably, maybe, play Connect the Dots, all right, but that does not show you a good relationship. All right, so we would draw that best fit line. All right, it's not touching 2 points, but that's because I freehanded that. Just excuse me. All right, so you can see that it is trending in the upward direction. We've got that positive slope. All right, and another thing that I wanted you to see here, all right, we do have this line graph, and remember that line graphs are used with quantitative data. All right, but if we look down here on our x-axis, all right, Monday, Tuesday, Wednesday, Thursday, Friday, that's not quantitative, that's not numbers. All right, but if you remember correctly, all right, days of the week, days are a measurement of time. All right, so this time is measured in days. Okay, so it is actually a quantitative measurement because it is time. All right, the next thing that I want you to look at is the label over here. Now, given the title, all right, we can assume what it is. All right, we know that that's temperature. All right, but we have no idea what unit it is in. All right, this could be degrees Celsius, degrees Fahrenheit, or Kelvin. It's probably not Kelvin. All right, but if it was degrees Fahrenheit, what we use, this could be really cold. All right, so it was just a really cold week. If we were using degrees Celsius, it was just a regular week. All right, 20 degrees is room temperature. All right, so it's always super important to use your units on there also. All right, so that's what we're going to be using. A pie chart. We will never use a pie chart. All right, pie charts are used for percentages, showing percentages. Okay, so remember last year in chemistry, we talked about how a percentage is part over whole times 100. All right, that's what we're looking at here. So in all pie charts, you are splitting up the whole thing. All right, so it could be a day, it could be a school district, it could be something to do with the football team, it could be a family, all right, it could be anything. All right, our example here is daily activities. So we'll say this is a student's daily activities, all right, and you can see that there are percentages down here. All right, so yes, there are percentages. Percentages are quantitative, but what we're really looking at is that it is a percentage. All right, so we'll say that this student, most probably accurate, is not spending 50% of his or her time sleeping. That's probably spent on social media and cell phones, if we're being honest. All right, I would say definitely not 30% of the time is studying. I would say maybe this would be sleeping, and then maybe 16% is other activities of the day. Okay, so that's just showing you how they are parts of a whole. There's also another one. It's called a scatter plot. All right, this one can be qualitative and quantitative. You're going to use these whenever you have lots and lots and lots and lots and lots and lots of data points. And normally they can trend in a certain direction. You wouldn't connect those with any line. You could just see the trend, or if there's not a trend whatsoever. All right, but like I said, we are going to be really focusing on these line graphs. All right, so I'm going to number these just so we can easily refer to them. Okay, so one of these is obviously not like the other. So number 9 right here is not like any of the other ones. There are no lines. This would be kind of what a scatter plot looks like. All right, but as you can see, there is no real trend. So there is no relationship whatsoever here. All right, now what we're going to really be focusing on is going to be 1, 2, 3, and 6. Those are those lines. You see the linear graphs there. All right, 1 and 2 have that positive slope. So we know that both of those are showing direct relationships, while 3 and 6 have those negative slopes. So they are showing those inverse relationships. All right, so we are really going to be focusing on those 4 whenever we do our 4-step method. Those are really going to be the only ones that you're going to be looking at. Now, that doesn't mean that we're not going to be able to interpret other graphs. Like if we look at number 4, all right, we just have that straight horizontal line. All right, we can interpret that. So as x increases, so as our independent variable increases, nothing is happening to our y. Our y is staying the same. So we know that our independent variable does not affect our dependent variable in any way. All right, so that's pretty much what we're looking at right there. Now, 5, 7, and 8 are different because they're curves. They're not straight lines. We are still going to see these types of graphs. You're going to be able to interpret them. I'm just not going to make you do a 4-step method on them. All right, so what I do want you to see is that they still have a trend. All right, so 5 is still trending down. It has that negative slope. So we see a form of an inverse relationship. Number 7 is trending up. So we have a relatively positive slope. So it's a form of a direct relationship. And 8 is kind of confusing to people. All right, 7 and 8 usually confuse people. All right, because both of them are trending up. So again, we've got a relatively positive slope, which is a version of a direct relationship. So these are all just showing you what types of graphs we are going to be looking at this year. All right, now on every single graph, we have 2 types of variables. Everybody should know these by now. All right, we do have our independent variable and our dependent variable. I had several students in years past who described, I would ask them, hey, what's the difference between an independent and a dependent variable? And they would tell me, oh, the dependent variable is the one that changes. Well, I mean, yeah, it does change, but so does the independent variable. All right, so we need to remember both the independent and the dependent variables change. It's just that we are changing the independent variable in our labs, and the dependent variable is changing because we changed the independent variable. All right, so if we look at an example, so we have a student, Alex, who wants to determine the amount of force, or if the amount of force an object hits the ground with changes when dropped from different heights. All right, so the first thing that we have to figure out is what is our independent variable and what is our dependent variable, okay? So we have to figure out what are we changing, okay? We are not changing the amount of force an object hits the ground with. We are changing the height at which these objects are dropped. So the independent variable would be the drop height. Now, as we change the drop height, so say we change or we increase that drop height, we are checking to see if that changes the amount of force experienced by that object. All right, so we need to be able to decipher between our independent variable and our dependent variable. All right, but once we do that, we can now graph it. All right, so these are a couple of things that I saw y'all struggling with, so I wanted to make sure everything is clear. All right, so our x-axis, which is our horizontal line, will always contain the independent variable. All right, that's always the one that we change. The y-axis, the vertical axis, will always contain our dependent variable. All right, so if we use the example from our last slide, Alex's experiment, we would have our drop height down here. And remember, we always have to have a unit. So we would say that was a drop height in meters, because meters is our SI unit for that. And then force was our dependent variable. And we will find out that force is measured in something called newtons. All right, so that's how we would label our axes. And another thing that I was kind of seeing some people struggle with is how to title these graphs. All right, so we always want to title it Y versus X or dependent versus independent. All right, however is easier for you to remember that. All right, so the title of this graph would be force versus drop height. Okay, so we have this title, and that title is kind of our introduction on what those variables are that we were looking for the relationship between. All right, another thing, this is just housekeeping. I did see a lot of people try to put your units in with your title. You don't have to do that. All right, if you just put your units on the axis that it goes on, that's perfectly fine with me. All right, so after we plot all of our points, remember, we are never, ever, ever, ever going to play connect the dots. Okay, so we always draw a line of best fit or a best fit line. And remember that it has to touch at least 2 points. At least 2 points. I've got my ruler on my screen right now, so we'll see how well this goes. All right, so, ooh, that wasn't too bad. Okay, so that would be our best fit line for this. Now, there are a couple of things. This was pretty good data, so I was able to touch each and every point. Oh, people are going to start coming in. Just give me a second. All right, so they're going to start, they need to touch at least 2 points and then be as close as possible to all of the rest of them as they possibly can. All right, now, what I want you to realize, I saw several people stopping their line right here and stopping their line right here. I don't want you to stop it right there. I want you to keep going past. I want you to extend that line. All right, so this is where we'll stop right now. I'll finish the rest in the next video.